Okay, hello everyone. Welcome to today's RISA Live. So my name is Cheng. I work in the tech support team. So today I will be showing you guys the steel joist design in RISAFloor. So for those of you who don't know RISAFloor very well, it is a great product in our RISA suite that can provide you a quick modeling for building type structures with member design and sizing under the gravity loads. So it is a little different from RISA 3D from the modeling perspective. The modeling in RISAFloor is based on each floor level, which means you will need to draw the framing members in each floor level, and then you can quickly populate the floor plan to a multi-level structure. So the program then determines the load pass from the framing layout, and it picks the member size for you based on the gravity loading. So if you need further lateral analysis, you can direct the model over to RISA 3D to continue the lateral design over there. So come back to the steel joist design. The program can do standard steel joist, such as the K-joist, LH joist from SJI. It can also do the joist girders, special joist with non-uniform loads, and virtual joist, and also a joist vibration analysis. So we are also currently in the process of adding composite joist design in the program. I'm working on that implementation with our developers and SGI. So hopefully it will be available in the upcoming release for you guys to use soon. Due to the time limit today, I probably won't get into too much details, but hopefully I can show you guys all the key features regarding the steel joist design in the program. You definitely can find more resources in our help file and our YouTube channel, but I also definitely feel free to contact our tech support if you have any further questions. So let's jump into it. Here is a model that I built for demonstration purposes. We can see I have some shorter span at the lower portion of the model where I use the K-joist, and have some longer spans at the upper portion of the joist where I use the LH joist. I also have some joist girders running horizontally, which supports these joists. So here in the next few minutes, I will show you how we can quickly rebuild this model and design this joist in RISAFloor from scratch. So let's get started. So if I start a new model, let's create a new floor plan first. So in this new floor plan dialog, we can give a floor plan a name, but here I'll just stick with the default floor plan 1. I will be using the beam supported floor plan type, and for the elevation, let's put a 15 feet for our joist elevation. For the default area loads, we do have a few preset lists. You can definitely modify these options, or you can add new ones if you need. For this model, I will just use the roof area loads for my floor. For the default deck, similarly, we have several options. But here, I will just stick with the concrete deck. The deck can go also just stick with 0, but you can change it if you want. So after that, I click OK. The next step is to set up the project grid line. So here we can see I have 2 bays at 50 feet in the Z directions. And in the X direction, I'm going to change it to say 30, 60. So I have a shorter span and also a longer span. So with that, click OK. I have my grid lines set up and ready for me to draw the framings. So we will start with the columns. So to draw the columns, we need to turn on the drawing tools, which is very similar in all the RISA programs. And if we go to the draw column button, click on it. So here I will just use some hot rolled wide flange columns to support my joist. If I click apply, I can either drop these columns by clicking individual joints, or I can just box over some areas, and the program is smart enough to drop the columns at intersection joints of these grid lines. So that's pretty quick modeling, convenient modeling tools. So after the column are drawn, I'm ready to draw my joist girders between these columns. So if I go to the draw beam option, first I need to change the material to steel product. Enter the shapes. We have all of the different joist types. And here I will select the joist girders and click apply. So similarly, I can either click from point to point between the columns, or I can just box over a region and the program will assign the joist, the beams between these columns. So if I turn on the shapes, we can see now these members have the joist girder shape type. This is the difference between RISAFloor and RISA 3D. So in RISAFloor, we don't need to input a member size because the program will analyze the loads and design the size for you. So now we're just seeing these members as a certain shape type. But say if I have, I guess, some certain height limitation for my joist girders, I wanted to specify explicit depths, I can definitely do that as well. So if I come back to the beam shape group, instead of the joist girders, we do have some preset joist girder depths. So say, for example, the 48G means we have a 48-inch depth joist girders. I can either use that or from one of the preset lists, or I can just come here and type in any number I want, say 44G, and use that for my joist girders. And we can see here, it shows 44G. That means the program will design the joist girders based on the 44-inch depths. After we finish the girders, I'm ready to draw my joists. So again, come back to the draw beams option, select the K-joist, apply, box over. Now I have the K-joist automatically drawn on my grid lines. That's my perimeter joist. So after that, I can use the infill beam option. So if I click here, change it to steel product, K-joist, I can specify, I guess, the spacing of equal spacing. I want less than 4 feet. I want the infill beams to run vertically in my floor plan view. So I click apply, and I click one click within the bay areas, and then I get multiple joists drawn at the same time. So that is a really convenient tool to just drop multiple equally spaced interior beams as you need. So that's pretty much for my lower portion. I'm gonna repeat that procedures for my upper portion with the LH joist. So I can drop the perimeter beams and then use the infill option, change it to LH, and then drop the interior beams joist as well. So that's pretty much about my framing. After the framing is done, I need to assign a diaphragm for my load distribution. So if I go to the diaphragm button, for this model, I will just stick with the default rigid diaphragms. If I click apply, the program will just trace the edge of the existing framing and assign the diaphragm based on that. Once the diaphragm is done, I can turn on my deck directions just to double check my deck is running in the right direction to transfer the loads to the joist properly. So I think we're almost ready to just do the analysis and get the design. Just one last step is let's just double check the area loads definition. So if I go to the area load definition spreadsheet, remember we were using the roof ones. We can change the number here, but here I basically have 10 PSF dead load and 20 PSF lab load, and I'm happy with that. But if you need, you can change these numbers or add new ones if you need it for your project. So close that and then run the project. We don't get any warnings, which is a good sign. If I close these, hide the deck display. Now in the model view, we can see the program already reports the joist callouts for us. So we can see in the lower portions, the program designs pretty much 22K7 joists for all of these. And then in upper portions, the program picked 40LH11. So these are our standard SJI joist callouts. So you can directly use these and send them to the SJI certified manufacturers. So similarly, for the joist girders, the program uses 44G, which was based on our previous steps input. And also it recognized there's a 13 equally spaced concentrated load from the joist with the magnitude of 13.2 for each. Again, that's a standard SJI joist callout. You can just use that to send to the joist manufacturers. So in this model view, if you wanted to output the results, you can either use the print report, which will print this model view to a PDF, or you can also go to the file, export, EXI file, and which will export these, the layouts and also the callouts to a drawing format, which can be used for your construction documents. So in addition to the model view, we can also check the results in the results spreadsheets. So if I open the design results, I go to the steel product tab, and we can see all of the joists are listed here with the girders and then the K joist. Scroll below, that's the LH joist. This spreadsheet summarizes all of the joist sizes and also the uniform dead load, live load, and total load for each joist, and also the maximum and minimum end reactions for the joists. So again, a great, I guess, a place for a summary of all the joist results. Another good piece of information for your project budgetary purpose is the material takeouts. So in this spreadsheet, the program summarized all different sizes of the joist and columns used in the project in this model, with the number of pieces of these shapes and also the total length and total weight. So with this, you can get a really quick preliminary estimation for your project budget. So that's about the spreadsheet. In addition to the spreadsheet, we can also use the detail report on the left side of the program to check the individual detail reports of each joist. So if I open these detail reports, I can see the detail diagrams for the joist and their different load categories, say live load, dead load, and also I can switch it to the load categories to see the diagrams over there. Also, if I scroll down in the detail report, we list all of the detailed summaries of the joist reactions, the member loads, the distributed loads, live load reduction considerations, the design rules being used, and also the utilization percentage for the joist strengths and also deflections. So a lot of good detailed information over there. That's about the standard joist design with uniform loadings. What if I have a non-uniform loadings? Say if I have a concentrated load, say 1 kip, and maybe I'll apply it maybe in the midspan of this joist, or maybe this joist, or just some places along the joist girder. What would happen then if we have these special loadings? So if I run a solution, I can see the program bumped up the joist size because of the concentrated loading, and also it added SP suffix after the callouts, which means now the program considers the non-uniform loading, so it picks a size with envelope capacity that is larger than the demand at any location along the joist. And then the SP suffix is an indicator that these joists may need further detailing by the engineers or the SGI certified manufacturers to ensure the adequate performance. So that's about the special joist. Just pay attention if you see these SP signs that may you may need to pay some additional, I guess, attention or requirements for this joist. So let's talk about the joist vibration analysis. So to perform the vibration analysis, first we need to select the right code. If I go to the global model setting, under the code tab, currently for joist vibration, we're following the SJI Technical Digest 5 guidance for the vibration analysis. So that is also the only available codes we have right now. So just make sure you select the proper code over there. And also another piece for the vibration check is we need to use, we go to the floor spreadsheet and the beam floors. We need to make sure composite deck is used. This is mainly because the technical guidance from the code is primarily focuses on the composite deck cases. So once we change that composite deck, we can go to the deck definitions and make sure we select a proper composite deck type for our project. If I click the right arrow, which will pop up the deck selection dialog, we have different databases from different manufacturers for different deck types. If you have a concrete deck that you wanted to consider the composite action, you can also use it in composite deck selection here. You just select it to concrete deck, and you can pick different depths and concrete weight types over here. So once the deck type is selected properly, the last piece is we need to make sure we have assigned our vibration load correctly. So if I go to the area load definition, remember we are using the roof area loads for the entire floor. We have the design loads, but then after that, pay attention to the vibration load VL column. So know that this vibration load is different from the design load. So we don't want to just use a summation of the design load that will be over conservative. We wanted to consider the real loads and weight that will participate in the vibration analysis. So this will be different from your regular design load, which is kind of the upper bounds for the demands you will see. So once that's being set, we can run the analysis and we can start checking the vibration results. So if I go to the vibration spreadsheet, we can see all of the joist results are listed here. For the beam M1, the program calculates the moment inertia of the joist, considering the composite cross sections. And the moment inertia will also contribute to the calculation of the mid-span deflection of the joist under the vibration loads. The program then calculates the natural frequency of the joist for vibration and also the effective panel weight of the joist areas. Note for these members above, the following 4 columns are empty. These are the columns, the properties for the supporting members. But these members are the joist girders, so they are supported directly by the columns, which are considered relatively stiff during vibration analysis. So that's why they don't have these columns available. Before the joist, which are resting on the girders, we will see we have the vibration analysis, the properties for the joist, and also the vibration properties of the girders which support the joist. Because the final vibration properties of the joist regions will come from the combination of 2 parts, both the joist itself and also the vibration of the supporting members. So the program reports the final natural frequency of the joist regions and also the peak acceleration of the vibration, which are the commonly 2 parameters that's being used for your vibration analysis. So note that the program only provides analysis results. This is because the design criteria could be very different for different systems with different usage. So you will need to compare your design acceptance criteria analysis results to finish your design. So that's pretty much about the joist design and vibration analysis that I wanted to show you. So before the end, I wanted to give you a quick sneak peek of the composite joist design that's coming up. So you won't be seeing this in your version because I'm using an internal testing version. But once this is released in the upcoming version, you will be able to see these options. But for composite joist design, this is very similar. You just need to go to the beams, steel product. Instead of selecting the typical joist, now you will have the CJ joist options for you to use in your design. And if you run the analysis, and of course, remember to use the composite deck because that's how you get the composite design. You get the typical SJI composite joist callouts with the stud numbers. If you check the material takeoffs, these composite joists, the weight and the length are included. If you go to the detail reports for this composite joist, you can see a lot of useful detailed information about the studs considerations, the composite section, properties, and bottom top chord designs and bridgings on all of these great details. So with this, that concludes my presentation today. I hope it was useful to you guys. If you like it, please definitely hit the like button and subscribe. Definitely leave comments if you have questions. Thank you for joining me today. I hope you enjoyed it, and we will see you next time. Thank you.